Okay, rest of you don't need that. Okay. So again, here are all your assignments. And if you have, if it's here, you do it. There's a lot of information on biomolecules coming up. I'll be lecturing on Monday again, or you may get more information in Blackboard. So if we look at a particular assignment here, notice that it has this material here. Make sure you read through all of that. Anytime you do these assignments, you can see the previous answers. Notice it's 3 of 30 right here. If you have a question for me, ask your teacher. If you want to keep notes, click here. So any questions you have, please go to ask your teacher, because when you use that, it will give me a copy of the question that you're working on. So let's look at this structure of an amino acid. Okay. An amino acid has carbon. This is carbon right here. This is hydrogen. Red is oxygen. And blue is nitrogen. Let's go back to Blackboard and open up the PowerPoint that we talked about last time. So we go to PowerPoints for lecture and chemical organization. Okay, so let's look at this. Let's review this chemical information. So any questions? I'm gonna go slide by slide, ask any questions. So all of this text and all of these concepts, I expect you to know. Okay, so an ionic bond. This sodium has 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. An ionic bond is formed when the sodium metal donates 1 electron to the chlorine, and chlorine has 17 protons. The chloride ion has 18 electrons, so it now has a negative charge, and the sodium has a positive charge. So all salts are ionic compounds. They're an attraction between a positive ion and a negative ion. Chlorine is the gas, chloride is the ion. A salt crystal is a regular arrangement of sodium and chloride. Make sure you know these names and these symbols. What's a covalent bond? Electrons are shared. Hydrogen shares 2 electrons. Oxygen shares 4. Carbon dioxide and oxygen have a double bond also. So 4 electrons are being shared. If electrons are shared, that's a covalent bond. If they're equally shared, that's a nonpolar bond. If they're unequally shared, that's a polar covalent bond. Hydrogen bonds are these dashed red lines. Water molecules are called a dipole. They have a slightly positive area around the hydrogens and a slightly negative region around the oxygen. So those are hydrogen bonds. Those help give water its characteristics of being a universal solvent, having a high specific heat. It takes a lot of energy to get water to boil because you have to break these hydrogen bonds. We don't care about this. 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 Okay, we do care about activation energy. So if a substance, if I have sugar and I want to burn that sugar, it's going to take a lot of heat to cause that sucrose to break down into carbon dioxide and water. In the body, enzymes are proteins that lower the activation energy. So reactions that would not occur outside of the body. So I can take sucrose and break it into fructose and glucose. So enzymes are not used up and they reduce the activation energy to promote a reaction. You don't need to know that. You already know that. Inorganic molecules are such molecules as water or oxygen. And you'll see that some of these questions are directly on WebAssign. Large molecules like sugars, proteins, and fats are composed primarily of carbon and hydrogen. And there, if something contains carbon and hydrogen and oxygen, it's an organic compound. Recognize carbon dioxide, what it is, recognize O2. Water is very important. It's an excellent solvent. It has a very high heat capacity because of hydrogen bonds, and it's an essential chemical reactant. So water has a slightly negative side and a slightly positive side. You can see that the chloride is negative, so the hydrogen ions of the water are attracted to that negative. For sodium, the oxygen, the slightly negative oxygen, is attracted to the sodium. So the water surrounds these sodium and chloride ions and it dissolves it. That's how dissolving occurs, when water molecules surround these ions. Hydrochloric acid is a strong acid. Acids release hydrogen ions. Sodium hydroxide is a strong base. We mentioned this already. So extremely acidic, extremely basic. Your blood is around 7.35 to 7.45. So urine is a weak acid, saliva, vinegar, extremely acidic, so up at these high levels. Buffers maintain the pH. They release hydrogen when the fluid is too basic. They absorb hydrogen when it's too acidic. Salts are electrolytes. They conduct electricity. You should know about carbohydrates, lipids, proteins, and nucleic acids. And we've been through this. Any questions? Glucose is often represented as a hexagon with an oxygen and a six-figured image. So glucose is composed of carbon, hydrogen, and oxygen, so it's an organic compound. Make sure you know about dehydration synthesis. If you take glucose and fructose and you have an enzyme available, dehydration synthesis will remove water and make a disaccharide. Enzymes can also break disaccharides into monosaccharides. So hydrolysis adds water back into the compound and breaks the disaccharide into two monosaccharides. Glycogen is called animal starch. When you eat a large amount of glucose, those glucoses are moved into the liver and they're made into glycogen, which is a branched structure of glucose molecules joined together. So glycogen is how we store excess glucose. Make sure you read through examples, primary function, and remarks. Lipids. Okay. So read through this. Okay. A fatty acid. A fatty acid has carbon and hydrogen on the one side, and it has oxygen and hydrogen and carbon. This is the polar molecule because oxygen tends to have a negative charge. So this fatty acid has this carboxyl group and this hydrocarbon group. If a fatty acid is saturated, it has all single bonds. If it has some double bonds, it's unsaturated. Triglycerides take 3 fatty acids and attach them to a glycerol molecule. These are fats. Notice the fatty acids are all carbon and hydrogen, so that makes them hydrophobic. They don't like to dissolve in water. Water-fearing, the carboxyl group here is hydrophilic, and if you have dehydration synthesis, you can join 3 fatty acids and release water. Hydrolysis will break those fatty acids away from the glycerol. Recognize the structure of cholesterol. Okay, phospholipids. This is the polar head. This is the nonpolar tails. Notice all of these tails are carbon and hydrogen. They're hydrocarbons, so they're hydrophobic, water-fearing, with oxygen and phosphorus here. This part of the phospholipid is hydrophilic or water-loving. Okay, let's stop there. And we'll stop that and have that individual recording.